So another new type of function for us to look at today. Let's look at something called logarithmic functions, often referred to as logs for short. So logarithmic functions. So a log function is of the form f of x equals log base a of x, where a is greater than 0, a is not equal to 1. Now, those conditions there, they just carry over from exponential functions that we did last time, and I'll explain why a little bit later. But those are the same conditions that we had for exponential functions for very similar reasons. So this is the form of a log function. So log is the common abbreviation for logarithm. There's a base a there, similar to how there's a base a on the exponential functions. And so let's see here. The other thing I want to put right up front here is y equals log base a of x means a to the y is equal to x. And so a couple things to say here about this. So, right back to that a is greater than 0 and a is not equal to 1, that comes from exponentials. The reason it comes from exponentials is logarithms and exponentials are inverses of one another. If you look at what I just wrote down here last, log base a of x equals y means a to the y equals x. That's very similar to what we were doing last time. Last time we were doing exponential functions, and those were a to the x equals y. And so in our log functions, we have the x and the y interchanged or inverted or whatever word you want to use. So moral of the story there is logs and exponentials are inverses of one another. And let's see, in this introductory video here, only other thing I want to put is that we do have a couple of special logarithms that we can look at in this section. They're not anything too extraordinary, but just so when you see me write them, or when you see them in the book, or when you see them in the homework, if you ever see log of x, that is shorthand for log base 10 of x. And if you ever see ln of x, that is shorthand for log base e of x. So we talked about e in our previous section. So natural log ln stands for natural log. I'm not sure where the l and the n come from, but natural log of x is log base e of x. So just two special ones there. We can talk about more in depth as we start going through this section. We'll do some similarities to exponentials. We'll look at the graphs for sure. But unlike exponential, these logs do have an interesting domain, so we'll look at the domain of a logarithm. That's one of our first things we'll do. The very first thing we'll do in the next video is, since this is a brand new function, and it's not like exponentials. Exponentials were at least a little bit familiar to us, but logarithms are brand new. So the first thing we'll do in our next video, our first examples, will be how do we evaluate these? How do we plug in a number? What number do we get out of them? Things like that. But then we will do some domain, we'll do some graphing, we'll do some finding inverses now that we know the inverse of an exponential function. So I'll start doing those in the next couple of videos.